Alright, so on this one, if we wanted to draw lines, okay, number 1, which corresponds to 3 over 29, so, which is this one, so that would be first. And then number 2, which is the last one, is here. Number 3, which is 1/9, which goes here. Number 4 was the first one, which is here. And then 5 was the second, the last one, which is there. So for that. So there's obviously more than one way to do this. The way that I like for personally is to write them all as fractions, then write them as decimals, and go from there. Yes?
What if you got the first one wrong?
Then it's all wrong.
Really?
Yes. Yes.
For 1/9 and 3, I got 0.1.
Well, because 1/9 is 0.19 repeating, so it's 0.111111.
I know, I got confused.
So I didn't draw the repeating part up there, but I had to take it out to several digits so that I knew it was different from the other ones. The first one is number 1, 329. Yes.
12 over 21, I but I had it in the
Right. Okay.
But okay.
Yeah. As long as the final order is correct. Yes.
I labeled it 1, 2, 3, 4, 5, and I for the answer got 3, 5, 2, 4, 7.
If it's not this, so it should be 4, 3, 1, 5, 2. That's wrong. And then number 2, remember a unit rate. They want the way to find a unit rate is whatever the denominator is. We want that to be 1. So if it's 1 minute, if it's 1 mile, if it's $1, if it's 1 donut, if it's 1 paper towel, if it's 1 pencil, we want the denominator to be 1. So in this case, the unit was minutes, so the denominator was 12 minutes. We want it to be 1. So what do you do to 12 to get 1? You divide by 12. So what are you going to do to 186? Divide by 12. And when you do that, you get 15.5 rotations, okay, in a minute. On number 3, this equivalent rate means that we have to convert something. So for number 3, we have miles to minutes, and we want to change that to feet and minutes. So we write the original, 5 miles in 1 minute. And I know that I have to multiply by a conversion to change feet per minute. So how do I know what to put on top and what to put on bottom? Well, my numerator, the unit is changing in my numerator. So whatever I multiply the conversion factor, I need to have in the numerator whatever the new unit is, feet, which obviously means that I have to do feet in miles. Okay, so I know that there's 5,280 feet in 1 mile. So I just multiply across 5 times 5,280, and I don't end up having to divide by anything. And you see these cancel, and you're left with feet and minutes. So 5 times 9. So I distributed the 21. So 21 times x is 21x plus 21 times 10, which is 210. And I set that equal to 9 times 56, which is 504. From there, I asked myself, what's being done to x? Well, 210 is being added and it's being multiplied by 21, so I'm going to work backwards. The opposite of adding 210, subtracting 210. If I subtract 210 from each side, these cancel. I'm left with 21 times what equals 294. Divide both sides by 21, and I got x equals 14.
There's a lot of
No.
You can cross
again-
multiply and divide.
Yeah, that's okay.
Yeah.
And then subtract
Cross
it.
multiply and divide and subtract it.
Yeah.
If you prefer that one.
I did.
All right, on this one, you would not need to look at the picture. In fact, looking at this would probably be more confusing because they have rotated them. So again, all this requires is angles and sides. So here are the angles. You just match them up. Angle J to angle A, angle K to B, L to C, M to D, N to E, and then O to F, and then the sides. So in order to get this problem fully correct, it would have to look identical to that on the test. Okay? Yes. Then it would be Russell. On number 12. 12 is more complicated than 13. So on these types of problems, what I do is whatever side I'm trying to find, that is the numerator in my first ratio. I look at this figure, the one that has what I'm trying to find in it. So here's the triangle. R, U, V. There's the triangle. I need to find this. I don't know this either. I don't know the side of VU, but I do know RU, because if I take 24 plus 12, I know that that side equals 36. So I'm going to put what I don't know over what I do know. And then from there, I have to look at the other triangle and match the side. So if I picked RV here, I would have to pick RT here. If I picked RU from this one, I would have to pick RS from here. Then I go back in and I fill in what I know. So I know that side RV is 25 plus TV. I know that side RU is 36. I know that side RT is 25, and I know that side RS is 24. So then I just set them up as an equation. I cross multiply, or I set them equal to each other. So I took 24 times 25 plus TV, and that equals 25 times 36. From there I use the distributive property. 24 times 25 is 600. 24 times TV is 24 TV, and that equals 25 times 36, which is 900. From there, I've got to get TV by itself, subtract 600 from each side, and that gives me 24 times what equals 300. Divide both sides by 24, and I get TV is 12.5, but they don't ask for what TV is. They ask for what RV is. So if RT is 25 and TV is 12.5, if you add them together, you get 37.5. Yes.
We didn't have to use TV. Yeah. So I used it without, I just had RV by itself and then 36 times 25.
Right. Yes. Yes. Now this one is a little bit more simple because you're not having to use the distributive property. Same thing. I set it up. Whatever it is I'm trying to find is the numerator to my first ratio. Then I look. Okay, I look at this triangle, the one that UV is from, which is right here, RV or RUV. miles on a map, how many miles is a half an inch? Now you could use mental math to find this out too, but how much is a half an inch? A half inch on a map with this scale would represent 125 miles. And again, the math behind it is 250 times 0.5, half of 250, and then you're just dividing by 1 here, so you don't have to really do that. Okay? Number 15, same thing. 1 inch is 250 miles. 1.5 inches is 1.5. How many miles is that? Cross multiply. 1.5 times 250. And then you're dividing by 1, and you get 375 miles for that. And again, that would be something that I'm picking on the label because there's a big difference between 375 miles and 375 inches. Okay? These, you set up the same way. 1 centimeter is 120 kilometers. How many centimeters would 60 kilometers be? So obviously this is going to be a decimal. You could look and say, okay, what did I do? 120 to 60, divided by 2. What's half of 1? 0.5. Or you could have, yes, or you could have cross multiplied 1 times 60 divided by 120. Could have done it that way. So same thing with this one. 1 centimeter represents 120 kilometers. How many centimeters is 300? Cross multiply 1 times 300 divided by 120 and you get 2.5. Yes. Yes, 2.5. Yeah. All right. On this one, a lot of people got confused on this because they thought it was counting principle. Most of the time, when it's going to be counting principle, they're going to tell you use the counting principle. But number 18 did not mention the counting principle. Right. Number, no, 19 is also probability. Okay. And then here, this probability, and this would be theoretical probability too, because it's not an experiment that we have performed. We are guessing what would happen based on what we know. Okay, so if we've got 20 blue marbles, 12 red marbles, and 8 yellow marbles, how many total marbles do we have? 40. So if I was to have a bag that had 40 marbles in it, and I picked out 40 marbles, right, and set them to the side, how many would I expect to be red? Well, 12, because there's only 12 in there, out of the 40, right? Okay, so I am going to do this experiment, but instead of picking 40 marbles out, I'm only picking 20 marbles out. So what is the ratio of red to the total marbles? 12 over 40. What would the ratio be over 20? 6. So you would expect it. Now there's a ton of different ways to do this.
So the answer is 6 over 20?
Or just 6. Yeah.
What if you put 3/5, like reduced it?
No, because that would be saying, but that would be saying that you just did the experiment 10 times. So they want to know how out of 20. So on that one. Now on the next one, so you're searching a rectangular field. How do we know that it's rectangular? Because the length and the width are not the same. So we're trying to find 100. We're searching an area like this, right? 144 feet by 96 feet. Searching all of that. You are only searching a little 12 by 12 area. Okay? So what are the chances that you are going to find this hidden prize? Well, first of all, you've got to figure out what's the total area being searched. I just did 144 times 96, and there's 13,824 square feet being searched. You are only searching 12 by 12, which is 144. So you put 144, which is what you're searching, over the top of 13,824, and you reduce. And when you reduce, you end up getting 1 over 96. So the chances that you're going to find this are 1 out of 96. Not that great of odds. Yeah. Okay, number 20 and 21. The confusing part about number 20 is that spinning the spinner have this spinner which has 3. The counting principle says you multiply. 8 times 3 is 24. The probability of spinning 1 both times, which is just one event, would be 1 out of 24 on that one. And then this last one, you just take, this is choice 1, choice 2, choice 3, choice 4. You have 2 choices for your main course. You have 2 choices for your next course. 3 choices for your beverage, and 3 choices for your dessert. So 2 times 2 times 3 times 3 is, you have 36